All right, Year 10, today I'm going to go through factorising polynomials. Now we're going to use the factor theorem and then we're going to do long division, but there's another way if you want to try it, which is a lot quicker and a lot easier. That's if the polynomial is indeed factorisable. Sometimes, as we know with quadratics, we don't get real factors or we get irrational factors like the square root of 7 or something like that. So exercise 10i is pretty easy. If I have a look at it now, solving those quadratic equations. You should already know how to do those, so I'm going to do them very quickly. So the first one, 2a, it's already written in its factorised form. So x minus 1 and x plus 3 equals 0. So we get what makes this, and I'm going to do this long, but I really wouldn't normally do that, either x minus 1 equals 0 or x plus 3 equals 0, meaning x equals 1 or x equals negative 3. And for the purposes that we're going to be doing this would be a parabola with a root at 1 and a root at negative 3. It's a positive parabola. And if I just look at what would happen when I multiply these two numbers, I get minus 3. So my y-intercept is down here at minus 3. And remember, the vertex is halfway between those two. So that'll be at negative 1. So down here I've got a vertex and it would look like that, the parabola. I don't need to find the vertex, and we're not going to go through sketching these, but note it was a quick way to find the y-intercept and the roots were really easy. Let's have a look at the next one, and I'm just doing the first column, 2d. We've got x squared minus x minus 12 equals 0. Again, this is a quadratic. It's a positive parabola, so it's going to look like that. I could go and find the vertex and do all that sort of stuff, but today we're just concentrating on factorising. I've got to find two numbers that multiply out to negative 12 and add up to negative 1. Remember, there's a 1 in front of that. So I'm going to have x minus 4, x plus 3. This is where knowing your times tables or your factors is important. And then I'm not going to rewrite that again. I'm just going to go, well, that means x can equal 4 or x equals minus 3. And again, if I was sketching it, and I'm going to get minus 3, so somewhere over here, and I'm going to get 4. And if I add those together, I get 1. What do? Yeah, get 1. So it's going to be going at a half somewhere down here. And if I multiply these two numbers together, I get negative 12. So down here, negative 12. And my parabola would look something like that. And there is a half and whatever value that would be. And you can see the scales all out, but I'm only doing these really quickly. So that's factorising quadratics. So when I'm factorising or trying to solve a cubic, so this is a cubic here, because I'm going to have an x times an x times an x, so there times there times there, I'm going to get an x cubed, and it's a positive cubic. Now the shape of a cubic, and I'm just going to create some room here. All right. The shape of a positive cubic looks like this. So a positive cubic can look like that, or it can just look like that. A negative cubic can look like that, or like that. Now, that means if I drew in an x-axis, I could have 3 roots, 1, 2, 3. I could have 1 root, and again 3 roots, and again 1 root. Right, so if I know that's the shape of them, the first one is a positive cubic, and it's got 3 roots. So it's going to look like this first one here. Oops, this first one here. So here I go. It's pretty easy because it's already written in factorised form. X plus 3, x minus 2, and x minus 1, I think. Let's go back and have a look. Righto, 3a, that's it. So my solutions are, well, what does make, and you got to think, what's going to make that equal 0? Oh, okay, x equals negative 3. And here x equals 2, and here x equals 1. I would write them in order from left to right, so I go, oh, x equals, oh gee, come on. X equals negative 3, x equals 1, x equals 2, because if I was drawing it, and I had my axes there, I'm going to get a root at negative 3, a root at 1, and a root at 2, which means my curve is a positive cubic, so it's going to go up, come down, and go up again. And if I join the dots, now, here's where you're really smart. What's that value there? All I have to do is multiply this number by this number by this number. 3 times negative 2 is negative 6 times negative 1 is positive 6, so that's positive 6. Now that's a really rough sketch, and as you can see, the vertical scale is different to the horizontal. If I was sketching these, and I'm not, I'm just finding where they hit here, here, and here. I'm factorising and finding what we call the roots of the polynomial. But if I was sketching it, that's what I would be doing. And that's in the next exercise 10G. But we're not worried about that at this stage. We're just factorising. So all these other ones here, they're already in factorised form, and you're just finding the 3 solutions. It's a cubic. They're all going to have 3 solutions. They're all going to look like that. And they're all going to have different solutions as you go along. I really want to just start concentrating on question 4, and they give us a step-by-step method here. So it says use the factor theorem to find the factor, use long division to find the quotient, factorise the quotient, and then write the polynomial in factorised form, and then solve. So I'm going to do one of these, really using that method, and then I'm going to show you another method. So here's 4a, and I've got my polynomial. So I'm going to write it as p of x, and it's a positive cubic, x cubed minus 4x squared plus x plus 6. Now, it may not be factorisable. I'm pretty sure if we're doing these that they're going to all be factorisable. They might have some that aren't, but I'm pretty sure if they've asked a question, they've made these cubics that are factorisable. You notice that they're all positive cubics, there's no negatives. Now, for solving quadratics, we have a method. We can use cross swords, we can use completing the square, we can use a quadratic formula, or if it's a monic, we can just use the product and sum. For factorising a cubic, there are methods and there is a formula, but we're not going to be doing it. We're going to just be using the factor theorem. Now, that means we're just going to guess and check, but our guessing is going to be a little bit more refined than just having a stab in the dark. And the thing that's going to help us is this. We need to guess numbers that multiply out to positive 6. So the numbers I'm going to guess are plus or minus 1, plus or minus 2, and plus or minus 3. They're the numbers I'm going to guess. And I always start with 1. So the first thing I'm going to do is I'm going to go p of 1. Now, if I don't get a remainder, then I get x minus 1 is a factor. So I'm going to go 1 cubed minus 4 times 1 squared plus 1 plus 6. And I'm going to go to my calculator here, sorry. And remember our method for doing this is we put our answer in, because we might have to guess 6 times to get this one here. So I'm going to go 1, press equals. There's my answer. Then I'm going to go my answer cubed minus 4 times my answer squared plus my answer plus 6. And I get 4. So P of 1 equals 4. So that is not a factor. So the very next number I'm going to try is negative 1. So now I just go negative 1, and I use the negative button, negative 1, press return. That's my answer. I'm going to go back up, try it, and P of negative 1 equals 0. So therefore, x plus 1 is a factor. Now here's where they say use long division. Okay, so I'm going to use long division. So I'm going to go x plus 1 into my equation, which is x cubed minus 4x squared plus x plus 6. All right, how do I make my leading term look like the leading term here? Well, I multiply by x squared. So I get x squared. I do that multiplication. X squared times x is x cubed. So my leading term looks the same. And x squared times 1 is plus x squared. I now do my subtraction. X cubed by x cubed, that goes. Minus 4x squared minus x squared minus 5x squared. And then the x and the 6 just drop down underneath because they're subtracting 0. Now, where's my drawing? Draw. There. Come back. Right, let's get rid of that. All right, so now how do I make the leading term look like 5x squared or minus 5x squared? Well, I multiply by 5x. And then I do the multiplication. That gives me minus 5x squared plus 5x. Minus 5x. Got to be very careful of the signs here. Minus 5x. And then I do my subtraction. Minus 5x squared cancels. X minus minus 5x gives me 6x. And I get a 6. How do I make that 6, that x look like 6x? Well, I multiply by 6. Oops, read up here. And 6 times x, 6x. 6 times 1, 6. Subtract, I get no remainder, which means I've factorised it. I've now found it. So that means my polynomial x cubed minus 4x squared plus x plus 6 equals x plus 1 times x squared minus 5x plus 6. And there's no remainder. Now, I can factorise that quadratic because I know how to do that. What multiplies out to 6 and adds up to negative 5? And they've both got to be the same sign. And I'm thinking x minus 2, x minus 3. All right? Now, I can quickly check them because if I now write 2, so go to my calculator, press 2, press equals, go back, press equals, I get 0. And if I press 3, press equals, go use my back arrow, press equals, and I get 0. So I know I've got the right answer now. So that's my polynomial. And what do they want us to do? Factorise, done. Write the polynomial in factorised form, done. And solve for x. Okay, so when does x plus 1, x minus 2, and x minus 3 equal 0? Well, that's when x equals negative 1, x equals 2, and x equals 3. And there's my solution. So what do you do again? You use the factor theorem and remainder theorem to start guessing, all right? But you're not guessing completely unaided. You're using the fact that you know that the numbers must multiply out to the constant. So you pick numbers that multiply out to 6. So as you can see, I started with 1. Always start with 1. It's the easiest to do. And then I went -1. And then I would have gone 2. And then I would have gone -2. And then I would have... Once you get them, you're right. So now I want to show you a slightly different way to do it. And I want to do it with a different one. So I'm going to go to the last one. I'm going to go to F. X cubed plus 6x squared minus x minus 30. So I'll just write that here. So this is for F. And I've got x cubed minus plus 6x squared minus x minus 30. Plus 6x squared minus x minus 30. And that's my polynomial. I'm going to write it as p of x. And now I'm going to try and find things that multiply out to 30. And as I said, I'm going to find p of 1. It's always my first go. And the numbers I'm going to try are 1, 2, and always plus and minus, 3, 5, 6, 10, 15, and maybe 30. I doubt 30. I don't think I'll be using that. So P of 1. Again, now, hold on. I'm just going to write it out. So I'm going to get 1 cubed plus 6 times 1 squared minus 1 minus 30. And I'm pretty sure that's not going to work, but I'm going to go through it with the calculator anyway. So 1 is my answer, so 1 equals. Now I write this equation. So my answer cubed plus 6 times my answer squared minus my answer, what? Back here. Minus my answer minus 30. And that's negative 24. And we're going, okay, that doesn't work. So now I'm going to try 2. I don't know. I reckon it's going to be 253 or 5. It won't be 5 and 6. It might be 3, 5. Yeah, 253, I reckon. So I'm going to try 2. So I press 2, hit equals, go back, try it, and 2 equals 0. So P of 2 equals 0. Now here's where you don't have to. So when we got to this stage last time, what they tell us to do is to do this polynomial division, but you don't need to. If this thing is factorizable, the next two numbers, right, so we've already got a 2, we've already got this thing here, so we're going down here, we've got x minus 2, right? Now it's got to multiply out to minus 30. So that means I've got to have a positive number in there. Now, 2, so now I've got to get 2 times something equals 30. So the 2 somethings have got to multiply out to 15. Because once I divide 30 by 2, I've only got 15. So it's going to be 3 and 5. So I go back to my calculator and I'm going to try -3. Because remember, -3, when I write it, is going to be x plus 3. So I go -3 equals, use my back arrow, and it works. So now I've got x plus 3. Now, if this is factorizable, I know what the last thing has to be, because this number and whatever this number multiply out to, it's got to equal 30. Now, I've already got 6, so the only number it can be is x plus 5. That's what it's got to be. So I go back to my calculator and I try -5. press equals, use my back arrow, press equals, and there we go. You don't need to do the long division if it's completely factorisable. Sometimes you might find a factor and then the quadratic that you get might not be factorisable. Well, how does that work? Imagine if you had a cubic that looked like this. So it only has one root, right? But you'd get your one factor, and then you'd have a quadratic here that would give you unreal roots. Okay, that's all you need to do to try and get through this. If I have a look at the questions, question 4 is important. And even though I've showed you how to do it, you should do a little bit of about half of them doing the polynomial division and the other half doing just guessing the factors. Now look at question 5. They give you a factorised one, but with a quadratic that needs a quadratic formula. Question 6, just take out the factor. Question 7, again, you guess or use a remainder and factor theorem to find a factor, and then you can find the other factors if you want, and try and get through as many as you can. Good luck with that.